All right, so this is your example 21. I think we talked a little bit about it, but we could probably just review a little bit. Okay, so we had three sets, A, B, and C here. And the universe was all numbers 1 to 20. So 1 to 19, 20, the integers. All right. So those are they're the universe. So all of these numbers should be in your diagram somewhere, even if it's outside of the circle. That's okay too. So we ended up putting all the numbers in and got this result. And then we had to find A intersection B. This is the first one. So I'll use the highlighter. So A intersection B is where A touches B. So that's here, right? So we ended up with 167 as the answer for that one. So how about B intersection C? Let's clean it out. So B intersection C, you've got your two circles, B and C. Where do they intersect? Here. Because you're in A, doesn't matter. I need to be in B and C. I don't care about that I'm in A or not, okay? So in that case, it's 6, 7, and 20 there for that one. I think you have this, the answer's already here, so there's nothing to copy, you just watch. So then the next one is A intersection C. So A intersection C is these two here, like that. So where does C touch A? So 6, 7, 8, 5, 6, 7, 8, 18. 5, 6, 7, 8, 18 there. All right. And the middle one, that next question is actually, where do the three sets touch? So this one here, A intersection B, intersection C, is where do they all touch together? And that can only be in the middle because that's shared between each of your sets. Got that? Any questions? Is that all right? So that's only 6 and 7 then. Now A intersects C, complement. So the last one is here. Let's do it in blue. So A intersects C, but not that. So think about where A intersects C is. A and C is here. This is A intersects C, right? But we want not that. Okay, so let me write that in. So that's A intersects C, okay? But it says complement of that, which means you need to write every number which is not in here. So that's why there's a lot of numbers written, because it's actually all of these numbers here are out here. All the numbers that are not in the intersection. And they should all be in here, okay? So it just takes a bit of practice, you'll get it. But we have to go fairly quickly because this unit's taking forever. So we're going to have to finish it fairly soon after next week. Okay, so in question 1, you want to look at this for a minute? I'm not sure how much I did last week or last lesson. If you like, you can make a Venn diagram, but I think you don't need to. So you've got A, which is 0, 1, 2, 3, B, which is 0, 3, 5. I want to find the intersection. So which numbers are in both? You can see you've got 0. So that would be an intersection, and 3, like that. So if you're making a Venn diagram, and always make a rectangle when you do Venn diagram, because there could be number outside here. So A and B, So the shared numbers are 0 and 3. They go in the middle, that's the intersection. And that means there must be 1 and 2 here that are not in B, but they're in A. So 1, 0, 1, 2, 3 is here. B, 0, 3, 5. And there's no numbers outside because we don't have a universe. So A intersect B would be the numbers 0 and 3. Like that. Okay, you want to spend 5 minutes on this and we'll do some answers in a minute. So just do those for 5 minutes. If you're on your tablet, or just write in your tablet. If you're on paper, just write on paper somewhere. But if you're using paper, you probably should buy a notebook and keep all your maths together. Because when you get your next worksheet, it's going to have all of these topics together. So quite a lot. Okay, so do that for a few minutes and then we'll go through the answers and see how you went. And you can also check the answer key, because on the file at the bottom, you can go and have a look at your answer key. It's down there at the bottom. Back in a minute. Okay, question A. We can take a look. Okay, so for this A intersect B, what did you get for that? Anyone? What's A intersect B? Remember to look for the numbers that are in common. So 0, 1, 2, 3. So actually A is a subset of B in this case. So 0, 1, 2, 3. For that. A intersects C. Let's clean the board a bit. So A intersects C. We've got, oh, only 0. Okay, so the shared element is 0 for that one. And B intersects C.
No.
Hello. Did I do anything wrong?
It's 0, it's 0.
Is that okay?
It's 0. Yeah.
Is that right? A intersects C. Yeah, there's only one element shared between A and C there. So B intersects C. So that's the same again, right? So 0, 0, that's a shared element. So 0, 0 for that one. 0, 0, 0, 0, 0. All right, so what? I don't like this zoom too fast. Okay, A, 2, 3, 5, 7, B, 1, 2, 3, 4, 5, 6, 7 to infinity. So this is an infinite set, but that's not a problem. So we've got 2, 3, 5, 7, and we find them in the set here. So A intersect B is 2, 3, 5, 7. Put a bracket. Like that, 2, 3, 5, 7. So this A is actually a subset of this infinite set here. All the elements are inside it. So A intersect B, 4 and 5, 0, 1, 2, 3.
No.
They're all different, aren't they? Which means that's an empty set. So if you were doing a Venn diagram, you'd have 0, 1, 2, 3, and B would be 4, 5. And we don't know what the universe is, but we just leave it empty. So in the next section, that would be called a disjoint set. Disjoint sets. So the intersection is empty, an empty set, nothing in it. Okay, so that's exercise 8. Now the union of sets, I didn't talk about that last week, did I? So the union of sets is all the elements that belong to both A or B, or both A and B. So everything. So union means everything here. This is your union, A union B. So it can be in both, that's no problem. It can be in A only. So this is A only. Or you can be in the intersection. So A intersect B, that's no problem. You can be in there. Or you can be in B only. There. So that's what I've written here. X such that X is an element of A or B or both A and B. So union includes the intersection that we just did there, right? So all elements that are in the sets. So in this question, we've got, in this example, we've got a universe, which is the numbers 1 to 10, natural numbers. A is 1, 2, 3, 4. B is 2, 4, 6, 8. 3, 4, 5, 6. So your first job would be to fill in the numbers into the diagram. Okay, so that's one thing you need to be careful of. So you got the question, make your 3 circles, and then put the numbers into the circles. So the first thing we want to do is union. So every question is about union, except that last one there. There's an intersection there too. So A union B. So that means everything that is in A or B or both. So that there is your A union B. And the numbers are written here. So 1, 2, 3, 4, 6, 8. Okay, so everything in A union B, including the intersection. So that's the first one. How about A union C? A union C would be everything in A union C here. Okay, this one here. So we've got 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. That's A union C. And then the next one, it's pretty easy, isn't it, once you get a hang of it? So let's erase the yellow. So B union C is the same idea. So B union with C, all of those numbers are in that set. So 2, 3, 4, 5, 6, 8. 2, 3, 4, 5, 6, 8 there. And number 4, so let's shade the area first. We might need a pen. So this is A union with not C. So we color in A first. This is A plus. So think of union as plus, including everything that is not C. So I'll use another pen for not C. So not C in blue. So not C is everything not in C here, like that. So everything I colored in is actually part of your answer, because this union is like an addition. So everything I colored in there is okay. So all of the elements should be written here. 1, 2, 3, 4, 7, 8, 9, 10. So 1, 2, 3, 4. Yeah, they should all be there. Everything in yellow is part of your answer, like that. So that's where you may make error, is in the shading at this time. So when you get good at shading diagrams, it will get easier to answer the problems. All right, but what about A intersect not B? So let's do that one. So we've got A. So let's do the A in red. So A is here. Intersecting. So now we're looking where the lines cross over. That's your intersection. And then we'll color in not B in blue. So not B. So now I color in not B. So color in not B, everything that is not B, like that. And because you're doing intersection, I only care about where the red and blue lines cross over. So that would be only this section here. You see that? Where the lines cross over, this area here. And 2, okay, down into there. Let's just check. A intersect not B. Yeah, yeah, down into there. Just checking myself. So that yellow area is your answer. So that's 1 and 3 here, like that. And if your shading diagram, remember to remove the lines you don't need anymore. And I'm not going to touch them because the yellow will disappear. So only the yellow area. Okay, so the last one. So the last one is A union B union C. So that's all A plus B plus C, everything, these numbers here. So union is basically everything. So A is here, union with B, union with C. So that's your answer here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 8. So all of the sets join together. That's it. And the last one's quite easy. That's your intersection of the 3 sets. So that's A intersecting B. Let's do that. So A intersect B first. A intersect B here. And where does that intersect C? This is the long way to do it. And C is here, right? So where do they intersect? Only the middle. So the quick way is just shade the middle. That's what it means. A touching B, touching C. So that has to be right in the middle there. So we only get element 4 for that one. Okay. You can review with the video because I'm filming it. Oh, that's a long example. Let's go to a question. But one thing that's very useful to learn is this rule here. This one and this one. You can read that example yourself anyway, but better we try a few questions. And this one here. You probably think this is going to be hard to remember, but it's not really. So this means the number of elements in the union of A and B is the number of elements in A plus the number of elements in B minus the elements that are in the intersection. Okay, so number in A plus number in B minus the number in the intersection. When you have 3 circles, we have this rule. The number in the union of A, B, and C is number in A plus number in B plus number in C. And then we subtract. We subtract each intersection here, each possible intersection, AB, AC, and BC. And then we've subtracted too much actually, so we have to add back the intersection, A, B, and C. Right? You're going to see this in some problems when you do word problems. Right? But you can read that example yourself. So let's look at some examples because we don't have a lot of time. Can you go to exercise 9? Take a look there. These are both union problems. So I'll give you a minute. So just write them out. Make a Venn diagram too. So just like I'm doing here. And then 2 here. Because you're going to see all these kinds of questions again later anyway. So we don't have to work on the example too long. So you're going to get A and B. And question 2, A and B. So make 2 circles. and fill them in. Put the numbers in first. Okay, I'll give you a minute to do that, and then we'll go on a bit. So union now, not intersection. So in question 1, you've got 0, 1, 2, 3. Which numbers would be in the intersection? 1 and 3. Yeah. So put 1 and 3 in your intersection here. Like that. And then 0 and 2 would be in A, but not in B. And B, we have 1 and 3 already in the intersection. So now put 5 and 7 in the remaining part there. So your union is just everything that I've written in, actually. So it'd be 0, 1, 2, 3, 5, 7, like that. Everything. Intersection would be only 1 and 3, like that. So that's your union there. But what did I write? I wrote A. So that should be A union B, rather. So that A union B. A intersection B is only 1 and 3. They're the numbers in the middle. Sorry if I'm a bit slow for some of you, but we'll take it slow because it's better you understand now and then try to work it out later. Okay, so for question 2, we've got 1, 2, 3, and 4. 1, 2, 3, 4, 5, 6. Actually, I want to change my diagram. Well, let's do it like this, but we'll change the diagram in a minute. You got 1, 2, 3, 4, and 1, 2, 3, 4 is here. Right? So actually, they're all in the middle. So 1, 2, 3, 4. There's nothing here. Okay, there's nothing in A only. And then the other two numbers are 5 and 6. They're in B, so they go there, like that. So your union will be 1, 2, 3, 4, 5, 6, which is actually the same as B. You'll notice that that set is B, isn't it? That's the same as writing set B. So that's your union, A union B. But if you get a question like this, I think it's better to change your diagram, isn't it? Why don't we make it a subset? So instead of drawing it like this, you've got a missing space here. There's nothing there. So what you could do is actually put A inside B, which will look a lot nicer. So you'll have B here. But why don't you put A inside as a subset? So 1, 2, 3, 4, like that. And then 5, 6 will be outside. So that's set A in there. But the answer will still be the same. The union is all numbers added up. So I think in a test, if you've got a missing space, you can try to join your sets. You won't lose marks or anything, but it just looks a bit better having it as a subset. So in this case, A is a subset of B, and we can see that from the diagram. Okay, so what's 12:06? When do we finish? 12:20, isn't it? Let's do this section, disjoint sets. Okay, so this is enough. We've already seen this already. When, for example, you have two sets, 1, 3, 5, 7, and 2, 4, 6, 8. So if you make a Venn diagram, you'll see clearly that the sets don't have any shared elements. That's A and B. So put A in, 1, 3, 5, 7. B is 2, 4, 6, 8. There's no universe that we know of, so there's no numbers outside. So we can see that the sets have no shared elements. So we can write it like this. The intersection of X and Y I should have called that X and Y, shouldn't I? Better. So the intersection of X and Y is empty, or you can write that as an empty set like that. So X and Y are disjoint sets. So you will see this as well. Some of the sets have no shared elements, so we call them disjoint. And we can say the union of them is the number in A plus the number in B, okay, because there's no overlap between the elements. So anyway, let's take a look at some. Here's an example. Okay, you can see two of these circles, C and B, are disjoint. They have no shared elements here. So if I was going to draw the diagram, I've got A, which is 1, 2, 3, 4. I put in the middle here. B is 2, 4, 6, 8, which is here. So some of the elements are shared between A and B. So we have some overlap here between A and B, that's okay. And then C is 3, 5, 7, 9. 3 is shared with A, but 5, 7, 9 is by itself here. Okay, so if you drew the diagram, you can see that B intersects C, it doesn't. You can see that because the elements are not shared, because I've got this one here, which is C, and B, which is way over there. They don't even touch at all. So we say that the sets are disjoint. Okay, B and C are disjoint. A intersect B is not empty. Here we've got 2 and 4. All right, oh, it's become green. Blue and yellow makes green, doesn't it? So now we got green. So that's not empty. And A and C also. A and C are not empty. So they are not disjoint sets. Any problems with that? Is that clear enough? Exercise 10. We may stop here because I think the next section, let me see what's after disjoint. Complement of set. Well, we may not get to that. Okay, so take a look here. We've got a universe, which is 3, 4, 5, 6, 7, 8, 9. A is prime and B is even. So list the elements of A and B. So you want to do that first? I'll give you a minute. So tell me what is in A and tell me the elements in B. And then thus show that the sets A and B are disjoint. So how are you going to show me they're disjoint? What do you do? All right, try that for a minute because I think our time is going to run out. I think if you show this, you would do that for part B because that's the rule that we just up previously that we saw. That's all you need to do there. So show that. Because it says show, so we have to prove it somehow. Okay. And your universe, only these numbers. So don't talk about any other number, only these ones here. So your next homework that you get for sets will cover all of these topics together. So it's quite a lot. And we've not actually finished everything yet. So set A, the prime numbers. So which are the prime numbers from your universe? 3, 5, 7, right? These are your prime numbers. Remember, prime number can only be written as a product of one and itself. So like 5, 7, 11, 13, like that. So that's set A. And the set B is the even numbers. Well, that would be 4, 6. Oh, but 9. Okay, so 4, 6, and 8. That's okay. We can ignore the 9 when we do this calculation here. So 4, 6, 8. So number in the union, let's make a Venn diagram. Like that, we've got A and B. So 3, 5, 7. Well, they don't overlap, do they? 3, 5, 7 and 4, 6, 8. So again, it's probably better to draw the circles separate like that, A and B, because they don't overlap. So 3, 5, 7, 4, 6, 8, like that. So the number in the union is 6. There's one element 9, which is outside, but that doesn't matter. So the number in the union is 6. The number in A is 3. The number in B is 3. And that's equal. 3 plus 3 is 6. 6 equals 6. So that's one way that you can show the sets are disjoint. So this is how to show the sets are disjoint. I think you do it this way. This will be the best way, using this formula here. There's no intersection, so we've got nothing on the end here. Okay, there's only 5 minutes left, but we can probably stop there. And the next section is actually about complement of the set.